Assalamu alaikum. My name is Majid and my department is BSBC, and I'm here to present the presentation of BC1. So first we talk about table of contents. Slide 1 is about primary standards, slide 2 is about acids, slide 3 is about bases, slide 4 is about oxidizing agent, and slide 5 is about reducing agent as well. Primary standard. A primary standard is in metrology is a standard that is sufficiently accurate such that it is not calibrated by or subordinate to other standards. Primary standards are defined via other quantities like length, mass, and time. Primary standards are used to calibrate other standards referred to as working standards. Primary standards are materials containing a known concentration of substance. They provide a reference to determine unknown concentration or to calibrate analytical instruments. Usage and criteria of primary standards. In order to be used as primary standard, a substance must meet four key criteria. It must be available with extremely high purity, and it must be stable under the conditions it will be stored and used. It have no water of hydrations and have no tendency to become hydrated. If it did, its weight could change with the humidity changes. Be of high molecular weight. This helps minimize the effect of small weighing errors. Examples of primary standard: oxalic acid, MOHAR salt, and potassium dichromate are some most important examples of primary standard. NaCl is also an example of primary standard. Why NaCl is an example of primary standard? Because sodium chloride, which is used as primary standard for silver nitrate AgNO3 reactions, zinc powders, which can be used to standardized EDTA, ethylene diamine tetraestic acid. Tetraestic acid solution after it has been dissolved in hydrochloric or sulfuric acid H2SO4. MOHAR method of primary standards. Because MOHAR is one of the most important examples of primary standard. A soluble chromate salt K2CrO4 is added as the indicator. This produces a yellow color solution as the silver nitrate solution is slowly added. A precipitate of silver chloride formed. This method determines the chloride ion concentrations of solution by titration with silver nitrate. As the silver nitrate solution is slowly added, a precipitate of silver chloride forms. The end point of the titration occurs when all the chloride ions are precipitated. Solutions of MOHAR method. The chloride ion concentrations of the MgCl2 and CaCl2 solution is determined by a precipitation titration with calibrated silver nitrate solution. This procedure is known as MOHAR method. Acids. An acid is a molecule or ion capable of either donating a proton known as Bronsted Lowry acid or forming a covalent bond with an electron pair known as Lewis acid. The first category of acids are the proton donors or Bronsted Lowry acids. It is the first category of acid. A chemical that gives you off hydrogen ions in water and forms salts by combining with certain metals is called acid. Examples of acids are those chemical substances that have a sour taste. Example: acetic acid and citric acid. Base is a chemical substance that has a bitter taste. Example: caustic soda and washing soda. Strong base: sodium hydroxide and potassium hydroxide. Base in chemistry. Base is a substance that reacts with an acid in an acid-base reaction. The mechanism through which a base works has been argued throughout history. Generally, a base either accepts a proton, release a hydroxide anion when dissolved in water, or donates an electron. Example of base include hydroxides and so. Examples of base in chemistry. Bases are those who gives hydroxide ions in water. Sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide, ammonia contributions and attributions. Some reactions of acid and bases. NaCl reacts as acid with NOH base to form salt and water. It is called neutralization reaction. HBr is an acid and HBr reacts with a QH base to form KBr salt and water, and both reactions are called neutralization reactions. Oxidizing agent. An oxidizing agent is a substance in redox chemical reaction that gains or receives an electron from reducing agent. In other words, an oxidizer is any substance that oxidizes other substance. Oxidizing agent is the substance which donates electrons or oxygen or gains hydrogen. In other words, oxidizing agent itself gets reduced. In other words, oxidized agent itself gets reduced. Oxidizing agents are those who itself gets reduced. Elemental fluorine, for example, it is the strongest common oxidizing agent. F2 is such a good oxidizing agent that metals, cores, asbestos, and even water bursts into flame in its presence. Here are the examples of oxidizing agents. A and B are oxidized and oxidizing agents. First of all, A loses electrons and B gains electrons. So A gets oxidized and B gets reduced. So A act as oxidizing agent and B act as reducing agents because B gains electrons. Here substance A undergo oxidation because resulting in an increase in its oxidation number. On the other hand, the oxidation state of substance B becomes smaller since it gains electron by undergoing reduction. As an atom transferring substance, an oxidizing agent is a substance that transfers at least one electronegative atom to chemical species in a chemical reaction. The transferred atom is typically an oxygen atom. Several combustion reactions and organic redox reactions involve the transfer of an electronegative atom between two reactants. Examples of chemical reactions: Fe2O3 plus 3CO form 2Fe plus 3CO2. Loss of oxygen Fe2O3 Fe2O3 जो है ना वो हमारे पास जो है वो रिड्यूस हो रहा है क्योंकि इसके पास ऑक्सीजन का लॉस हो रहा है, जिसकी वजह से इसका ऑक्सीडेशन नंबर जो है ना वो डिक्रीज़ हो रहा है। तो इस वजह से ये हमारे पास रिड्यूस हो रहा है। और जो हमारे पास कार्बन मोनोऑक्साइड है वो हमारे पास ऑक्सीडाइज हो रहा है क्योंकि इसका ऑक्सीडेशन नंबर इंक्रीज़ हो रहा है। The example illustrated above, the Fe2O3 molecules act as oxidizer by transferring an electronegative oxygen atom to the carbon monoxide molecules. Reducing agent. In chemistry, a reducing agent is a chemical species that donates an electron to an electron recipient. Examples of substances. Example. Substances that are commonly reducing agents include the earth metals, formic acid, oxalic acid, and sulfite compounds. Examples of substances that are commonly reducing agents include the earth metals, formic acid, oxalic acid, and sulfite compounds. In their pre-reaction states, Reducers have extra electrons, that is, they are by themselves reduced, and oxidizers lack electrons, that is, they are by themselves oxidized. Chemical reactions of reducing agents. F2 act as an oxidizing agent uh, because it gains electrons. So Na positive act as a weakest oxidizing agent because it contains one electrons. The strongest of the atoms depends upon the oxidizing number of the atoms. The stronger the reducing agent, the weaker is the corresponding oxidizing agent. Fluorine gas is known to be a strong oxidizing agent, and whereas F negative is said to be a weak reducing agent. We also know that the weaker acid, then stronger is the conjugate base. Similarly, the weaker the oxidizing agent, then the more strong is the corresponding reducing agent. Thank you so much. This is all about from my side, and I hope so you get well from this presentation. And Allah Hafiz.